Hey, it's Dr. B. This is a video about dot plots and how they can be used for sequence alignment. I'm sure you've been reading about them in the chapter, but this is just a simplistic example to kind of give you an idea about how this is used. It's been used for many years. There are other more sophisticated ones, but this is just to kind of give you a pretty good idea about how one way to do sequence alignment. So basically what you do is you can see here that we have two sequences, this one, and they're clearly not alike. But the question really is, how alike are they? And so what do? We basically take the first sequence, and I just had put it down in this row, and then the second sequence going across the top. And then there's a couple different ways you can do it. It's called dot plot because some people just like to put dots in there, but I like to put the actual letters. So basically what we're doing is we're finding if there is any sequence homology anywhere. And so when we find the same letter in a row that we find in the column, we put that letter in the corresponding box. So for example, T and a G don't match up, and the first place I find a T is right here. So they both have a T, and so I do that, and I keep going across, and everywhere I see a T, where the row and a column match, I put a letter. And I repeat the same thing here for an A. And you can kind of see how this would fill out. So what I'm going to do is stop the video and show you first what this would look like if these sequences were identical, and then I'll come back to this and show you how we would do this particular dot plot. So this is what a dot plot would look like if the sequences were identical. And you can see here that these two sequences are identical. And so once we apply the same principle and put the one sequence across the top and the other sequence down the bottom, everywhere that we find the same letter, we put that letter. And you can see there's obviously more than one. But what we see here is going right down the middle, absolutely 100%. In the middle, all of these align in a straight line. That's the key. The straight line, or I should say the diagonally straight line, is an example of the same basic nucleotide or residue on both sides. And so this is what one would look like, and clearly you can interpret that at every single column and row there's a match, so therefore that's 100% matched. And remember, a computer would be doing this fundamentally and wouldn't really know, would be aligning all of them, but says, oh, wait, every single time I see a row and a column match, every single one of those accounts for every single residue of the connection. So that's what one of these would look like if there was a complete match, but that's not always the case. So let's go back to ours. So I just went ahead and filled out all the rest of these because that would have taken a long time for the video. And you see that we do have some homology here, and especially in this area right here, GATTCG. That is based on the rest of the length of the rest of this. That would be the area of alignment because there are the most residues in order back to back. And we can see here that there's also three more. So this is a very good sign that this area right here is where those two sequences overlap. And by the way, consider if these things were, 150 nucleotides before and after, etc. This is where you can find the homology. So this is the use of a dot plot fundamentally to just kind of give you an idea about how they show homology and percent homology. So in other words, if this particular sequence happens to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 nucleotides. We have 1, 2, 3, 4, 5, 6. We have 6 out of 17 nucleotides in complete alignment. And then we have 8 out of the 17 in a partial alignment. So depending on what your purpose was, both of those values might mean something to you. So as you're practicing a dot plot, this is basically what I'd expect when you were handing in some sort of version of this. The homology doesn't necessarily have to be in the middle. And as you read, sometimes they could be skewed to the left, skewed to the right. But the whole identifying mark of the residue comparison sequence alignment is going to be whether they are diagonally oriented. So for example, you might have you might have a series of something like this, like here, and then maybe here, again, assuming that all these letters are the same. They don't, and this is one that's just kind of giving you an idea here. You could have that scenario go on. And so that's where you could have more than one of these, but I'm just kind of giving you an idea. And the basic purpose of this exercise at this point in the course is to be able to understand what a dot plot is and be able to make one.